So starting with a convenience, a lot of these are little convenience things. So getting the ID of the last run container. This is something you end up having to do a lot. And so you can do this. You can do $ID equals $. This is what all the samples do. And this makes a lot of sense when you're making a script that has to get a whole bunch of IDs in a row. You've got the ID for MySQL and the ID for this other thing. But when you're running things interactively, it's kind of a pain to have to keep doing that. So what I do is this. I say alias DL, which in my head is Docker last, equals Docker PS -L-Q. So what that'll output is just the ID of the last run container. And so then you can use it interactively on the command line, like docker commit backtick DL hello world. And so, so wherever you have to do a container ID, you can just do backtick DL instead, and it's a lot less typing. You don't have to keep moving the mouse over there and copying and pasting it. Tip number 2. So this is why you always want to use a Dockerfile, even if you like installing things in the shell. So I like installing things in the shell sometimes. I'm not dogmatic about it. I don't think you always have to use a Dockerfile for the whole dang thing. I've found that in the end, even if you're building up, if you're doing all your installation in the Docker, just in Bash, you end up wanting to do a Dockerfile anyway. And the reason is that if you're not doing a Dockerfile, you do stuff like this. So Docker run Bash, and then apt-get install Postgres, and install a whole bunch of other stuff, and you've got this really sweet image, and then you exit, and then when you commit it, you have to say -run equals single quote, open brace, double quote, cmd, double quote, colon, bracket, double quote, and it just gets to be insane. Because what you're doing is you're trying to enter the JSON all on one line, the JSON for the command that's going to be run later on when you want to run this image. It's a pain. So even if you end up building your whole image in Bash, it's better to make a wee little Dockerfile that has from the image that you made interactively, and then in there you can set up the Docker specific stuff like the command, entry point, volume, and so on. So that's the general idea. It's sort of like a post-processing step on building the image interactively. So sudo. You end up having to do sudo all the time. And this is for those of you who say I'm pronouncing sudo wrong. Maybe it rhymes with voodoo. I don't know. But in any case, however you say it, there's an easy way to do this. And this is a beginner tip. This is actually mentioned very early on in the Docker documentation online. It gets to be really annoying very quickly typing sudo all the time. So you make a Docker group, and you add yourself to it. You restart the Docker service. You log out. You log back in again. No more sudo. Taking out the garbage. So Docker, if you want to delete all the stopped containers, after a while you end up with just a crap load of containers. And even just Docker PS slows down, which is surprising. I'm not sure what's so slow, because Go is pretty fast. But you can delete all the stopped containers with this command, docker rm, and then docker ps -a-q. It's a little different than my -l-q. -a-q is all the containers, but just list their IDs. And conveniently enough, this will try to remove all the containers, but will fail on the ones that are still running. So yay, because you didn't want to delete those ones.
What if this behavior changes?
What if this behavior changes? Da! Con! All right, so JQ is the gangsta way to parse Docker inspect's output. So back to JSON. If you are doing Docker inspect, and then you're doing stuff like this, Docker inspect, grep IP address, cut -d, -f4, blah, blah, blah. I don't know. I mean, to me, that's hard to understand. Yes, you can just put it in an alias, but sometimes you're just doing stuff on the fly. And so JQ is something that you can just install with apt-get, and it's a JSON post-processor. So it will take JSON and parse out the little bits that you told it to. In this case, it is more typing, but it's easier typing, because it makes more sense to me. So like in this example, the dot just means start with everything, and then bracket 0 is the first element of the array, and then .network settings, .IP address. Just think of it as JavaScript accessing a JSON object. And so it's really handy for parsing the output of Docker inspect. Tip number 6. What environment variables does an image have? Sometimes you want to know that. You're wondering, in my image, I've created this now, what does the environment look like? Well, this is a little easy one. You just run env on the environment. Replace Ubuntu with your image name, and there it is. And then you just see it. This is especially handy later on with my last tip, which is when you are using names and links to link containers. So the run command versus the command, or the run versus command instruction, beginners sometimes get this a little confused. So run will be run when you Docker build. So, and then command will not be run when you're building. Command gets run when you Docker run. Sorry for the confusing sort of alter ego thing there. But it's important to get that straight. So you should run when you're building up the image, when you're basically installing software and adding stuff to the static file system and stuff. And then command means this is what my image will run in the end. Here's another point of confusion: command versus the entry point instruction. So there are actually, I won't go into all the details of how command and entry point are different and can be used separately and together. But if you use them separately, then in the first Docker file, it's using command echo. So that means, so if you, on the Docker file, it just says command echo. And then if you say Docker run my image, echo hello, it's going to replace the command with whatever I typed. So the output is hello. With an entry point, it's not replacing it. It's adding whatever you typed to the end of the entry point. So if you type Docker run echo hello, it actually outputs echo hello, because that's getting passed into the echo entry point. So does a Dockerfile have its own IP address? This is a little confusing when you're starting to use Docker because, well, is it a process? Is it a VM? Yeah, it's a little of both. So it does have an IP address. That's really easy to prove just by looking at its IP address and, from inside itself compared to the IP address from outside in the host. Number 10, Docker's architecture. So you can have some fun with this. So it's a thin command line client and a REST server daemon running over a UNIX socket by default. So you can override it so it's not running over a UNIX socket if you want to. Up until, I don't know, version 0.5 or 0.6 or something, it was running over a port, and now it's running over a UNIX socket so that it's not controllable from the outside world. You can still override it and tell it to run over a port if you want. You can also do fun stuff like this. You can, from the host, connect to the UNIX socket and pretend you're an HTTP client. So netcat straight to that UNIX socket and just type in get/images/JSON HTTP 1.1. Hit enter twice because the HTTP header expects two enters, meaning that's the end of the command. And there's the output right in your console. So I did that one day when I accidentally committed an image whose name started with a dash because I typed the order of options wrong, and it said, great, -rm or something. And so I was going, well, how do I get rid of this? When I tried to remove it, the Docker RMI command keeps thinking that I'm typing an invalid option. So I connected straight to the socket and just told the REST server to delete the darn thing. I could have also, there's other ways you could do it. I could have rerun it on a port and then run curl, but it was kind of fun doing it this way. Number 11, graph the dependencies among your images. So the Docker images command has a -viz option, which is cool. It outputs a file that you can pipe to ImageMagick. And then to see it, one way to see it is to run this on your host and then hit your host in a browser, port 8000, and hopefully it doesn't look like that. That's fake. That's not a real one. Here's a little example, a little sample screenshot from a real one. But they can get pretty big if you've been working for a long time. They won't look all hairy, though. It'll be more like a tree with lots of lines coming down like that. Number 12, where does Docker store everything? So spelunking into the internals a little bit is always kind of fun. And Docker stores everything in varlib docker. So if you switch to the super user and cd into varlib docker, it's not only fun, it's educational to go in there and see what's going on. It's pretty obvious the containers are stored in the containers directory. The graph, not quite as obvious, that's the images. And then the volumes is the volumes. Like if you want to see the file system layers, like the layer upon layer upon layer, then you go inside graph/image_id/layer, and now you'll see what was done in that layer for in that layer of the file system. And then using the parent hierarchy, you can look at each individual layer and see how stuff was stacked up. Docker source code. I'm a developer more than I'm not really a sysadmin, and so I like to look at source code. So it's all in Go, which is really cool. Go seems to have hit an inflection point. It's getting not just Docker, but a lot of stuff is starting to be done in Go. So these, to me, are the 4 most interesting files to look at in the Docker source code if you want to take a look at it. Commands.go is the command line interface. It's a thin wrapper around the REST API. And so the Docker team tries to make sure that people aren't adding commands that have a lot of logic in the command line. That's not the way they want it to work. It's just a dumb wrapper sending stuff straight to the REST API. So then API.go is the REST API router, and server.go is the implementation of much of the REST API. And then buildfile.go is the Dockerfile parser. So if you're ever wondering, like, how does it work? I don't get it. Well, it's open source. Look at these files. Like if there's something, Dockerfile, a command that you don't understand how it works, look in buildfile.go, and you'll see what it's doing when it comes across that Docker command. The penultimate one, penultimate is my second favorite word. So the penultimate one, so you run some daemons and then you exit the container. What happens? Newbie mistake, but a common one. And the answer is don't do that because they just go away. If you do run followed by something that starts a daemon, or daemon, again, pronunciation, then it's just going to go away. And so the run command is for things that affect the file system or expose ports or things like that. I mean, actually, no. The run command doesn't expose ports. So it's for things that affect the file system. And so you should run those instead by actually having the daemon be the main foreground process, or in the case of what the Relate IQ guys were saying, have a startup script if it needs to that starts daemons and then starts the main process. Last one, letting containers talk to each other. This is the coolest. I saved the best for last. So this is the hot new feature in 0.6.5. And so it's been touched on a couple times in the talks today already. You run a container, you give it a name. In this example, my container is a database called loldb. I just made it up. And then you run another one, and you run it with -name to give that container a name. Then you run another one with -link, and you pass in the name of the original and an alias that you'd like it to have inside the second one. You can, of course, use the same name if you don't care to alias it differently. And then what it does is it sets up a bridge, a network bridge between these two containers. And so this is how you can have something like a Rails app in one container talking to a database in another container, and not exposing ports out to the outside world. It just has a network bridge between the two. It's awesome. It's very cool. And what the second container needs to know is it needs to know what the alias name is, like in this case, cheese, and the port number that it would normally be on, so that it can look up the port number that it's actually on in the environment. All right, thanks everybody.